Welcome back. In this lesson, we're going to continue the graph of cosine, right? We've done from 0 to 2 pi. This picture should look familiar to you. And next, we're going to do from negative 2 pi to 0. So we're going to do the half. No, we're not doing a half. We're going to do one cycle on the other side. We're going to keep everything. Meanwhile, if you like to review what we've done before, right? Going through, the ARD and fill out all these numbers, right? Go ahead. You can pause this lecture and then do that, so you can really be warmed up. Okay, so let's continue. Look at the other half, the other side. Okay, from negative 2 pi to 0. Okay, we're not going to do as detailed as we did before, because it's going to take so much time. I don't think that is even necessary. I'm going to select some points. Okay, we're going to select some points. For example, we can select negative pi over 3. Okay, negative pi over 3. We already see the entire curve, right? But we want to see some points. We want to see some points, okay? And so cosine. Okay, so the first set of questions I'm going to give you, okay? So I'm going to set up a table once again. I'm going to set up a table, right? On this table, I'm going to give you the question: what is a cosine negative pi over 3? Negative pi over 3. How do we get that value? Okay, from ARD's perspective. Well, once again, right, we're going to measure the angle from standard position, and this is a negative pi over 3, so we're going to go clockwise right there. And on the terminal, we have the red number is X value, the blue number is the Y value. And cosine negative pi over 3 is going to take the red number, right? Now, so this is going to be equals to half. It's going to be equals to half. And what is that going to be reflected on the graph, right? Once again, the same idea, okay? The very same idea, right? Negative pi over 3 will be measured from the same place, the origin. Because it's negative and it measured, clockwise on the unit circle and on the cosine curve, that arc length is going to be, okay, measured clockwise is pi over 3. So this arc length is going to be the same as this straight line, the same length, and negative number, negative pi over 3, right? So cosine negative pi over 3, the input is pi over 3, the output is half, and the red value, okay, the red value, what is the red? Is going to be this piece, which is the same as this piece, really. Okay, which is the same as this piece, okay? Next, we're gonna put the red, make it standing up, okay? So once again, the input is the arc length or the radian of the angle, right? Negative pi over 3, and the red number, right? There's a physical horizontal line will be standing up. Okay, so I'm going to skip a couple. Let's look at negative 2 pi over 3. Negative 2 pi over 3. Okay, so the question for you is, what is a cosine? Okay, negative 2 pi over 3. What do? We still measure clockwise because the angle, right? So we're going to measure clockwise, right? Clockwise is from here, continue to measure, terminal, right? So we have a terminal, and that terminal is going to be right here. Okay, and there we go. We have that point, which is a red number. It's -half. So we already know this value. We already know this value. Okay, -half. Okay, so now that golden arc length, or the angle measured by radian, right? That's going to be straighten up. Okay, so from here, from the same place to measure, -2 pi over 3, right there. And the ratio, which is going to be the red output, right? The red output is -half, right? So that -half is now standing up. It's negative because it's beneath x-axis, okay? So we keep going. Okay, keep going. You can select -4 pi over 3, and there are a bunch of other numbers we can choose. So we're getting closer to -2 pi, right? And I leave most of these numbers for you to calculate, really, because we've done the positive sides, okay? And we will quickly get to the other sides. Hopefully, this time we can afford to be a little faster. -11 pi over 6, -11 pi over 6. So I'm going to selecting this number, okay? -11 pi over 6. Okay, so what is that? -11 pi over 6, right? -11 pi over 6, that angle is going to be measured from the standard position, right? All the way, that arc length. Okay, so that should change to orange color, right? Change to orange color. So that arc length is measured from here all the way, okay? -11 pi over 6, all the way here. You guys see that? Okay, and then where's the terminal? So I'm going to bring the terminal into our picture, okay? And that terminal is right there. It ends in the first quadrant, and the red number, √3 over 2, √3 over 2. And that orange arc length is going to be measured from the same place, starting and ended up there. So that's how long is -11 pi over 6, and it's in the negative direction. It's in the negative direction. Does that make sense? Okay. Now the red number is √3 over 2. Okay. So now we can write cosine, okay, -11 pi over 6 is equals to √3 over 2. √3 over 2. Okay, and what is that √3 over 2? Well, it's that red number, right? Red number has a physical presence, right? Which is right here, which is the same length as you do it here, really. Okay, so we have all these red. So on this side, we're gonna have these scattered red bars, which was lying on the unit circle. Now they're all standing up. Okay, right here. There, boom. And we can mark the points, right? So let's mark these 3 points, right? We have -pi over 3. The output is half. Cosine -2 pi over 3. Its output is -half. And we have this guy, -11 pi over 6, and we get the points right there. So now the points, right? Their respective points. And this point for that guy, I think I'm going to mark it this way. Okay, mark it this way. Negative pi over 3, if you guys could see it. Okay, sometimes we have too much, right? 1/2. If you need to pause when you're watching this piece, just go for it. Okay, so this is negative pi over 3.5. I prefer you write the precise number. In this case, 0.5 and half are the same, so it doesn't matter. For negative 2 pi over 3, right? The output is a negative half. So there we go. We have that point marked, right? And this other one, okay, this other one, which is negative 11 pi over 6, right? And the ratio is square root of 3 over 2. And that point is marked. Okay. And I, of course, in this case, I prefer you mark the precise value, which is root 3 over 2 on your notebook. Last one we're going to do is 2 pi. What is the cosine 2 pi? We know that cosine 2 pi is what? It's 1. Yes, right? Cosine, the full circle, the red number, right? Now, label that. Oh, negative 2 pi. Sorry, I forgot the negative sign. There we go. Okay, so this point, okay, which is the bar, is going to be the red long one, right? The long red, which was here, the whole thing, and that whole thing now is standing up on this cosine curve. On this cosine curve. All right. So by this time we have completed from negative pi to negative 2 pi to 0 and 0 to 2 pi. Okay. So knowing the relationship we have repeated so many times, I hope you guys got it. So now I'm going to show you the picture. I'm going to show you the picture from both sides, on both the, wait, I need to clear that, right? Turn it off. Anyway, so now I want you guys see all of these points we have studied physically. Okay. There. From negative 2 pi to positive 2 pi. What do you see? What do you see? What do you see, guys? From negative 2 pi to 2 pi. They look symmetrical, don't they? Do they look symmetrical? Right? Let's look closer. Pi over 3, negative pi over 3. For negative pi over 3 and pi over 3, the output are the same. Okay? So now what do we, let's make a table. Let's make a table. Okay, this time I'm going to make a table. Okay, what table I'm going to make? Let's see. Horizontal seem to be better. Okay, horizontal because we can use the space more efficiently. Okay, you see negative pi over 3, pi over 3, these inputs are opposite and outputs are the same. Inputs are opposite, outputs are the same. You see opposite inputs, right? Negative 2 pi and positive 2 pi, the negative 2 pi over 3, positive 2 pi over 3. The output is the same, negative 0.5, right? If we keep looking, right? Negative 11 pi over 6, 11 pi over 6. And you might be thinking, maybe we have lots of these points. Absolutely, we do. We do. Okay, so this means that for opposite inputs, okay, for opposite input, oh, hold on. I'm going to make the same orange color. Okay, I'm going to make the same orange color. For opposite input, arbitrarily, okay? So I'm not going to make it land on a special place, right? So this is X, right? And this is it's opposite. It's opposite, right? So let's mark that if this is x and this is a negative x, the opposite inputs. And what are the outputs? The outputs are the red, right? The outputs are the red. Oops, give me the red, please. Give me the red, okay? And the red output are the same for opposite input. And this is true for every possible input, every possible input. And what do we say? What kind of function is this? That's right, even function, okay? So I'm going to give you a group of numbers for you to do this, okay? To see it for yourself, okay? So I'm going to clean it up. So we start with the numbers we already just talked about, right? So for pi over 3, right? And its opposite, what's the opposite of it? Opposite is, of course, negative pi over 3, right? So what is the cosine of those? Cosine pi over 3, right? And this is a cosine of negative pi over 3. There you go. There. Do they have the same value? Yes, they do. What is that? 0.5, right? 1 over 2. And this is not only true because by definition, you have to guarantee that every such points, every pair of opposite inputs, they produce the same output. And these are just some of the examples, right? So that's one pair. So I'm going to give you another pair. The other pair we look at is negative 2 pi over 3, right? 2 pi over 3, negative 2 pi over 3. And pretty soon you realize, you see that on this picture, you see that on the unit circle, isn't it? You see these on the unit circle, don't you? You see the red number? The red number? They are the same across the what? Across the x-axis. You see negative half, right? That's 2 pi over 3. You measure counterclockwise 2 pi over 3, or you measure clockwise. Okay, so let me draw these pictures so you can follow what I'm saying. So when I measure the angle, I get a negative 2 pi over 3, which is the terminal over here. If I measure counterclockwise, counterclockwise, okay, 2 pi over 3, so I terminate over here. So these two angles are opposite to each other. And their red numbers, that cosine ratio, are the same. They are the same, which is, right? So cosine, so I'm going to just write it over here. Cosine, and over here, cosine, there was the output. Cosine 2 pi over 3, right? That's a negative half. And the other one is also negative half. So that's negative half. And that's also negative half. That's also negative half. From these observations, right? And we check to see, yes, this is true for any input and its opposite, right? Any pair of input and its opposite produces the same output. So even function. How about in terms of increasing, decreasing? In terms of increasing, decreasing, of course, we sometimes go up, sometimes we go down, right? So this is the entire function. So you can say that cosine function, okay, cosine function is neither increasing nor decreasing on domain. What is a domain? We mentioned that earlier, right? All real numbers, because you can measure any angle, right? So far, we have gone 2 cycles. If you keep going, it's just going to keep going. There's no broken place. Every input is possible. The curve is nice and smooth. So on domain, the domain is from negative infinity to positive infinity. There you go. Okay, so cosine is neither increasing nor decreasing. Is it 1-to-1? Is it 1-to-1 if it's even? Of course not. If it is an even function, it cannot possibly be 1-to-1, right? Because they have so many pairs, opposite input produces the same output. And that violates the domain, the definition of 1-to-1, right? Because 1-to-1 requires any pair of different inputs must produce different outputs. And we certainly have violated that, right? So cosine is not 1-to-1, right? Not 1-to-1. See, we apply these definitions, but we also know that cosine function is even. Even, then it is not odd. But do we have intervals of increasing, decreasing? Yes, right? Intervals of increasing, decreasing. From -2 pi to negative pi, that's decreasing. From negative pi to 0, that's increasing. From 0 to pi, that's decreasing. Increasing, decreasing. So it's going up and down, okay? So let's put together a narrative about the increasing, decreasing on different intervals, right? So we can say cosine A, right? You can use X if you want to, is increasing on which interval? There's so many of them, right? I can say from negative pi to 0, that's increasing. Negative pi to 0. Okay, which we refer to this piece. Okay, so let me show you that piece. Okay, so that piece. On this piece, it's increasing. Okay, on that piece is increasing. So that's what we're saying. And we can also say, right, cosine A is decreasing on what? On the next interval between 0 to pi. Okay, if the increasing or decreasing, these are intervals where the functions are 1-to-1. Cosine is 1-to-1 on each one of these intervals. So you can keep going. We can make many statements as such to describe this phenomena, even though it is not increasing, it is not decreasing on the domain, but it's increasing on some intervals and decreasing on other intervals. So this second interval right here, right? Increasing, decreasing, increasing, decreasing. So these are just examples that we can give you to describe the functions increasing or decreasing. Summarize, okay? Domain and range. Domain and range. Okay. Domain we have mentioned, right? Domain of cosine. What is it? All real numbers, right? All real numbers. It can be any measurement, arc length, right? You can go around and round forever, right? What is the range? There are 2 aspects to look at the range. Okay? So let's clear all the drawing. One aspect is on the unit circle. We have worked out, right? If you look at all the red numbers, what is the smallest you see? The smallest we see is -1. And what is the largest we see? positive 1. Are there any red number that's larger or smaller? Larger than 1, smaller than negative 1? I don't see any. Do you see any? I certainly don't see any. Okay, so this tells us, right? This tells us the range is most likely between -1 to +1. But we only see special values, don't we? How about those numbers in between? Well, absolutely, you will have numbers in between in the range. For example, if you have a terminal, right? You have a terminal. This terminal, if it's not on the special terminal, it could be anywhere in between, right? And you'll have a bunch of red numbers for those points. So really, the output can be anything from 0, -1 to +1, right? The largest being 1, the smallest being -1. Okay, do we see this? Do we see this on the graph? Do we see that on the graph? I think we do. I think we do, don't we? Horizontally, okay, in both directions, right? The golden bar. Okay, so we clear out and redraw, right? The golden arc length can be any length, okay? That's the domain idea. How about the range? How about the range, which is in the red color? The range, you can see the entire curve. It bounces up and down, right? Up and down, right? Down, up. But it doesn't go beyond 1. It doesn't go beneath -1. So it's bouncing between -1 and +1. And as we saw, the numbers are red, right? They never get out of the interval from -1 to +1. Okay, therefore the range is between -1 to +1. And of course, we have favored form. We have favored form to write them, right? Our favored form of writing the domain and range or domain range together is a cosine A, okay, between -1 to +1. Okay, you can say for any real number, okay, you can say that, okay? Or sometimes people simply just make that statement, right? They simply just say the absolute value. Where's my symbol? Okay, over here, okay? Cosine A, the absolute value is less than equals to 1. Okay, sometimes we just say that. And of course, it's nice we would mention the domain, which is all real numbers. Okay, so these are two typical way of introducing, well, I'm talking about the range. In particular, this piece, okay, can be very useful in calculus class because it can be used in algebraic manipulation for example, the squeeze theorem, right? Squeeze theorem. Let's see anything else. I think we have covered pretty much everything, right? We covered the function, it's a function, we covered the graph in details. We see symmetry, right? Which is even function, it's not a one-to-one, increasing, decreasing on specified intervals. And I think that's all for the graph and domain and range for cosine. Okay. Thank you for watching. I will see you next time.